We have seen that variables are memory spaces in the program in which they are defined. Memory spaces that are given a name. They are created when the program starts to run and are destroyed when it ends. So, memory space is associated with the variable at the beginning, and unless otherwise specified, every time we refer to the variable by name, it will look for that memory space. For example, if within the program code we find this assignment to the variable NA, which is numeric, the program will assign that value to this memory space. And if later in the program we find this assignment, the memory space will be overwritten. However, if after assigning 99 and before assigning 10, we request new memory space for the variable, the previous space will be lost and a new clean space will be associated with the variable. If at this point, before moving on to the next statement, we ask what value the variable NA has, it will tell us 0. And if we now execute this other statement, the value 10 will be assigned here. If we do nothing to retain it, this space will have become inaccessible. Working with variables, then, will require keeping this in mind. We will be working with memory spaces that are referenced by the variable name. So far, we have seen variables that are defined with a simple data type. By simple, we mean singular. That is, a single item of information, whether it is basic or structured data. Here we see examples of numeric, character or varchar, boolean, date, among the basic ones, and the structured variable of type SDT AttractionInfo that we created in the previous video. Note that in any case it represents a single item of information, even if it is a structured item. But variables can also store collections of items, both basic and structured types. We can visualize it graphically like this. Variable A is a collection of 3 items of type numeric. B is a collection of 2 items of type character or varchar. C is a collection of 3 items of type boolean. D is a collection of 2 items of type date. And the E, on the other hand, is a collection of 2 items of type SDT AttractionInfo. In short, a collection variable is an ordered list of items of the same data type, regardless of what that type is. If it is AttractionInfo SDT we had already defined in our knowledge base, then let's see how we would define a collection variable of this data type. We had the Show Attraction web panel. So let's create another one in plural, Show Attractions. First, let's define, as we did before, an AttractionInfo variable of the SDT data type of the same name. And now let's define another variable, which we will call AttractionsList, which will be a collection of items of type AttractionInfo SDT. So far, there is no difference with the previous variable, but we will modify the default value of the isCollection property, changing it to true. This is how we tell it that it will be a plural SDT and not a singular one. This turns this variable into a collection. We can see this in the icon that appears next to the variable name. Thus, when the endAttractionInfo variable is executed in the web panel, it will already have reserved memory space, and the endAttractionsList variable will be an empty list. That is to say, pointing nowhere. Let's imagine that we want to populate this list with 2 hard-coded items. How would we do that? We could assign a value to each of the members of the AttractionInfo SDT variable, which will produce this. And then we would have to make this list point to the memory space of this variable instead of nowhere. We achieve this with the add method on the collection variable. We are asking it to add the item corresponding to the memory space of this variable to the collection referred to by this and attraction list variable. Now we want to add another item to the end of the list. To do this, we will have to request new memory space for the end attraction info variable. This causes the variable now point somewhere else, different from before, with all empty members. Then we assign values to its members. Then we add this item, which now corresponds to another memory space, back to the AND attraction list collection. This will cause a reference to this item to be added at the end of the collection. And so we could keep adding items to the collection successively. If we didn't want them hard-coded, but rather taken from the database, for example from attractions in France, we would do so by using iterations of a for each. If we don't want to discriminate between the first iteration and the others, once we are at the first record retrieved from the for each, the first thing we do is request new memory for AND AttractionInfo. Then the SDT members are loaded from the attributes. Since no value is assigned to the last member, flight arrivals, it remains empty and 0 will be displayed on the screen. And the item is added to the collection. Then we enter the second iteration, this time for this record. Memory is requested again for AND AttractionInfo. The assignments to the members are executed, and the item is added to the collection again. We'll do this in our web panel. In the start event, that runs, as we have been saying in previous videos, only once. When it is opened, we write inside the for each on the attraction entity. Let's not add any filters so that all attractions are loaded. For each one, we request memory for AND AttractionInfo. Assign these members to the variable. And finally write the collection variable AND attractions list. Period. And here all the possible properties and methods are suggested. In particular, we see the add method, which is the one we want. We want to add the corresponding item to the AND AttractionInfo variable. Once this code has been executed, we will have loaded the collection variable into memory with all the tourist attractions in the database. That is to say, something like this. To see that this works as explained, we will add a grid without a base table to our web panel, with these simple variables that we will need to add. Then, in the load event, we will have to run through the collection item by item. For this, we have the for in command. What do we have to place after the for? A variable that will be automatically manipulated by the command, and that will point each time to the item in the collection indicated to the right of the in. We could use the same variable we had used before to load each item in the collection. At the end of the start event, it will be pointing to this memory space, that of the last item. But that doesn't matter, because when used in the for in, it will automatically point, iteration by iteration, to each item of the collection. Thus, it will start by pointing to this item, and the body of the for in will be executed. We can then associate the values assumed by the members of the current item that interest us with the grid variables, and load a line. At the end of this iteration, the for in automatically makes the variable point to the next item in the collection, and then the next line of the grid can be loaded, and the same for the last item. Let's add all this to our web panel. We insert a grid into the web layout. From here, let's create the new variable id, which assumes the domain ID by default. Then the new variable name, a country name, and a city name. Now let's select these 4 in the order we want them. Okay, we can now see the grid with its 4 columns. Now let's go to source and add the grid1.load event. There we write the 4 in command as we presented it before. Let's run it to test it. F5. Show attractions web panel. There we see the grid with the 3 tourist attractions that we currently have in the database. As we have said, a collection variable will be an ordered list of items of the same data type. To manipulate this ordered list, GNexus provides methods that can be applied to the variable, such as these. We have already used add to add an item to the collection. If we want to remove an item from the collection, we use remove, whose parameter is the position number occupied by the item to be removed. So if we specify that we want to remove the one in position 1, this will happen. To clear the collection, leaving it empty, we have the clear method. We can also obtain the number of items in a collection using the count method, which will return 0 if it is empty or a positive number indicating the number of items otherwise. For this example, the result will be 3. Finally, we can sort the items in the collection. If it is a collection of basic data, then it will sort them according to the value of each item. And if it is a collection of structured data, as in this case, then we can instruct it to sort the collection according to one of the members of that structure. For example, according to name, and the result will remain in the same collection variable, which will now have its items reordered. And if we want to sort it in descending order, it is enough to place straight brackets around the member's name. The item method allows us to retrieve a reference to the memory position occupied by the item at the specified position. So if the position is 2, it returns a reference to that item. We could assign this result to a variable of the same data type as the items. The other possibility is, given the memory position of an item in a collection, to request the index of that item. In this example, the result will be 2. What we did, creating a grid with variables and running through the collection item by item in its load event to load its lines, was only to show how to run through a collection with the 4 in command. We could have loaded the grid in a much simpler way. Let's delete the grid and insert it again. Now choosing, when asked to select the variables or attributes to insert into the grid, the collection variable directly. Let's choose the members of each item that interests us. When we press OK, GNexus automatically detects that it is a collection and configures the collection property of the grid with the variable's value. This means that it is no longer necessary to write code to run through the collection manually and display each item in the grid. GNexus does it for us. It knows that the grid is a collection, it runs through it, and displays each item automatically. Therefore, the load event is no longer necessary. Let's run it again to test this. We see that we get the same result. The only noticeable difference we can see is that here the variables are not read-only. But we can always go to the layout and change the read-only property of each member of the variable to true. In summary, simple variables are used to store a single value, while collection variables allow us to handle lists of data, both basic and structured, and apply methods to handle them. They are ideal for displaying dynamic data on screen without modifying the database.